So we are talking the quadratic formula. But can you remind me what it's for? Yeah.
Finding out the roots of a parabola?
Roots of a quadratic. Okay. So we are finding the roots of a quadratic. Okay. And how does that look on a graph? Tell me. Yeah.
The roots of the x-intercepts?
They're the x-intercepts. So if I've got a curve like this, the roots are here and here, which is when the function of x, which would be potentially in the form ax squared plus bx plus c, that's when we have f of x equals 0. Right, so we're solving equals 0. Okay. Our first step when we're trying to find those 2 points is to try and do what? It's going to be a boring video. What do you do first if you're trying to solve it for equaling 0? Yep.
Write out the quadratic formula.
No, before we do the quadratic formula, actually, what have we been doing before? So if I said to you, I kind of asked you this question yesterday, x squared plus 8x plus 16 equals 0 exactly. We try and factorize first, and in this case I would have x plus 4, x plus 4, which would also be x plus 4 squared. Okay, and what would my solution be?
-4.
So x equals -4. So this is an example of, well, what was this one called again? No. Perfect square. It's called a perfect square because we end up with both brackets being the same. So actually, because this is what we have to keep in mind, what would a perfect square look like if I drew the graph? Would it cross my gun?
It would just touch the x.
Yeah. Where would it touch? This side, this left, right? Not in the middle?
No. Oh.
It would be on the left, wouldn't it? -4. It would touch at -4 and it would come down and just touch it once there and go back up. Okay? Where would it cross the y-axis? Yeah.
Plus 16.
At 16. And I use the, do you remember what it's called, that form? Someone had it. What form is it called? So this is factorized form. This was standard form, yeah? Alright, so we can use the standard form to find the y-intercepts. We use factorized form to find the roots. Okay, and we had another form which was
Linear?
nope. Vertex form, yeah. And what did we have to do to put it in vertex form? What was it called? Big booklet of notes on it, lots of questions. Done less than 24 hours ago.
Completing the square?
Completing the square. Alright, so we've completed the square to put it in vertex form. Alright? Okay, so what happens if we can't factorize? That's the question. Alright? Let's say I have a graph So I know the graph, and it crosses the axes just like any normal one, okay, like this. But the answer is going to be like 1.563, so on, and 0.563, so on. Right, what if they're the numbers? How are we going to be able to factorize them? Well, if we have a quadratic, let's say, let's go 3x squared plus 2x minus 5 equals 0. And you might look at that and go, that's not going to factorize. Some people, even when it does factorize, look at it and say, I can't factorize it. And some people think, well, it's got 3x squared at the beginning. It doesn't divide by 3. Even if it does factorize, one of the brackets is going to be 3x. No, it's just going to make it harder. So I'm just going to go straight for the quadratic formula. So the quadratic formula does the job, but don't forget, the quadratic formula solves the equation. It doesn't give it in factorized form. It just goes straight to solving it. So anyway, what's the quadratic formula? Do you remember it? You memorized it already? This is a recap.
Is it negative b plus or minus the square root of 2a? Oh, divide by 2a. B squared plus minus 4.
Okay. Where a is the x squared parameter, b is the x parameter, and c is the constant. So just to make it very clear, the sign goes with it. The x doesn't go with it. But b is always with the x parameter. A is always with the x squared parameter. Okay. So is this a bit of a recap for you then? Do you remember how to do it? So we put the values in. So we end up with x equals minus 2 plus, and do you know why it's plus and minus? Okay?
The square root is going to be positive.
Spot on, yeah. Square root could be positive and negative. So then we have divided by 2 squared minus 4 times 3 times negative 5. Any ideas why I put it in brackets, the 4AC? You may not have done it before, but some people do, some people don't. Bradley?
I guess done first before you.
Exactly. Well, before I do the bit with the b squared as well. And we've got to be very careful with the negatives. Right. Now, again, I'll offer this piece of advice. People don't take it. They just chuck it straight into their calculator. My advice is do it step by step and record what you do. Take the extra few seconds it takes to write it down so that you can check just in case there are any mistakes. And mistakes get made. All right? So although you can use the quadratic formula at any time to find the solutions, factorization, quite often people make less mistakes. There's lots of mistakes possible in here, especially with the negative numbers. So I just go through it step by step and do the bit. So minus 2 plus or minus the square root of 4 minus 4 times 3 times minus 5 is negative 60. I forgot to do 2a here. All over, that should be 2 times 3. So 6. That then gives me x is negative 2 plus or minus the square root of 64 all over 6. This is quite a nice one. That then gives me x equals minus 2 plus square root of 64 is 8 over 6, and the other solution is x equals minus 2 minus 8 over 6. So I split it there and then do finish it off. So that means x equals negative 2 add 8 is, so that's 6 over 6, which equals 1, and this one would be negative 10 over 6, which is negative 6 recurring. Okay, so there's my two solutions. So on a graph, that would now look like, so where it's just off, this value would be 1, and this value would be negative 1.6 recurring. That's what it would look like. Does that just recap for you? Okay, let me ask, do you need to write notes? You still going to want me to stop? Or pause? What I want to do though, if you're all okay with that, I want to talk about the determinant. Okay. Do you remember what the determinant was? We did talk about it briefly yesterday. Yeah.
So that would determine where the parabola is on the y-axis.
Actually, that's not why I would be calling it a determinant, actually. But, no. Do you know what the determinant is? It's part of the quadratic formula. The determinant is b squared minus 4ac. It's that bit. That's called the determinant. And it determines how many solutions there are. So I mentioned it yesterday. So if that bit is equal to 0, there is one solution, which means it touches and goes back up. If b squared minus 4ac is greater than 0, that means we have two solutions, which means my graph will look like the ones we're used to. And if b squared minus 4ac is less than 0, which means negative, we have no solutions. All right? And that looks like when it doesn't touch the axis. All right. Do you appreciate why that is the case? Why would that be so important, the determinant that determines that situation? Well, where is the determinant in the formula? What happens to it? Before that, go back to the formula. You've written the notes. Where's the determinant in the formula? It gets square rooted. Alright? So the determinant gets square rooted. So maybe you can think then, y if the determinant is 0, why do we get one solution then? Because what we're actually doing is we're doing plus or minus the square root of 0. And what's plus and minus the square root of 0? 0. So we're not plussing and minusing anything different. Okay? So we only get the one solution. Plus 0, minus 0. If it's greater than 0, that's when we're saying we're doing the square root of a positive number, which will have a positive solution and it will also have a negative solution. So you have minus b plus something and minus b subtract something, and you'll get two different answers. Yeah? And why will this one have no solutions then? Because it's going to be a negative in there. So let's say that's negative 3. Let's say this would be 5, 5, just in case. If it's a negative, can't do that. So that's why there'll be no solutions, and you'll know it doesn't cross the x. Okay? And that's why. So if the determinant is negative, okay. So quite often a question will be written and the statement will be at the beginning of the question, a quadratic has two real roots. It'll make that statement at the beginning of the question. What do you think that means? Yeah, so two real roots means that whatever the quadratic looks like, it's going to cross twice. What does it also mean? It means that b squared minus 4ac has to be greater than 0. If I say a quadratic has one real root, what do I know? That b squared minus 4ac is equal to 0. Good. And it will cross only once. It will touch it once. So that's kind of the important thing about the determinant. You can use the determinant, and sometimes these problems can be solved only using the determinant and not needing to use the whole quadratic formula. Okay? So maybe you're asked to solve for b, or So, if I said to you, 4x squared plus 2x plus c has one real root. Find c. What could we do? See, that line, that first line, should start you down a process immediately. Frankie, what do you think?
It would be
What should we do? What's our first step?
Find the square of 4. So
Now, what's the first thing I should write? Let's ignore that. What if I see that? First thing I should write is, Darius, help him out. What's equal to 0?
4x plus 2x.
No. I know that b squared minus 4ac equals 0. That's a, b, c. So I can write that 2 squared minus 4 times 4 times c has to equal 0. Alright? Make sense what I'm doing here? So I have to know this bit though. I have to understand what that means. So now I can say 4 minus 16c equals 0. What do I do at this stage? I need to isolate the c. Algebra skills. Minus 2. I could minus 4. What would it look like if I minus 4? So if I subtract that 4, negative 16c equals minus 4. That's fine, I could do that. It isn't what I would have chosen to do, but it's absolutely fine. What statement can I now make? If negative 16c is equal to negative 4, then c equals negative 4 divided by negative 16. So c is a quarter.
What would you have done? It would have been quicker.
I wouldn't have been any quicker. I would have added 16c. So instead of subtract 4, but all I would have ended up with was, if I'd have added 16c, I would have got 4 equals 16c instead. So I would have ended up going 4 divided by 16 is c, but we kind of got there, we just got negatives, that's all. There's nothing wrong with it, so I said it's perfectly acceptable. My route is just to try and get rid of any negatives if I can. And quite often, when people do the subtract 4 bit here, do you know the common mistake that gets made? No.
They forget to subtract 4 from 0.
No, they do that actually. They would subtract 4. They would do that fine. They would get the minus 4 here. That's fine, but they do one thing wrong. Yeah? Well, I don't want to divide by negative 4. I want to divide by negative 16. The problem that they have, which is commonly made, is that they think that... Oh, I don't know what's fun. Maybe you can pay attention. This subtract, they think, disappears when you're taking away the thing that you're subtracting from. So they subtract the 4, and the 4, if you think about things disappearing, 4 disappears magically, and this is no longer needed. That subtract sign is no longer needed here. So they would actually be writing just 16c here. But Frank told us perfectly correctly, if I subtract 4, it is negative 16c. So we didn't make that mistake. But that can be a common mistake. And then, of course, you would end up with an answer of negative a quarter at the end rather than positive a quarter. Yeah? But that's how I mean, this would be the top end of the type of question that you'd have to do. But that's how I can find... Do you see how I could ask you to find A or B or C by telling you how many roots it's got? Yeah? Okay. I'm done talking.